Hello, everybody. We're going to take a look at adding and subtracting fractions with different larger denominators. This will be a bit more challenging than the last one. This is Unit 2.5C in WAMAP. And these are our problems. 1/56th plus 5/42. And the second one, 9/70ths minus 1/105th. Starting to look more interesting. Let's take a look at our tablet and see what we think. I'm not seeing the tablet on here. Let's pause. Okay, I found the tablet. I'm not sure what's happening, but I seem to have two versions of different tablets on the screen. Well, we'll see how it goes. So, first thing we notice, we're adding something, and whenever we add or subtract, we know that we have to have like terms. They have to have something in common. And so with fractions, they have to have the same denominator. And so that may be a little bit challenging to find a denominator when the denominators are 56 and 42. So this is the point at which you really have to abandon all guesswork and just apply the rules slowly and methodically to get to your answer. So we're going to go back to our prime factorization pattern. So we're going to take out a 2 and get 28. And we're going to take out a 2 and get 14 and take out a 2 and get 7. So we're going to find the least common multiple by doing a prime factorization. We're going to be at the buffet and we're going to take all the some of everything, and we're going to take the biggest dishes they offer. So let's say 42. We can take a 2 out of there, so let's start there. 21 and 3 and then 7. Okay, so we've got 2 cubed times 7 and 2 times 3 times 7. So as far as the buffet goes, we definitely want to pick up that 2 cubed. That's going to be enough for everyone. You'll be able to share that with everyone at your table. And then we need to get a 3 and a 7, so it doesn't matter where you take those from. And so we've got what we need right here. 2 cubed is 8. 2 times 2 is 4. Times 2 again is 8. Times 3 is 24. Times 7. 7 times 24. Let's see what that is. 168, it looks like. So that's going to be our least common multiple. And that means that 56, I guess, goes into that 3 times. And 42 goes into this 6 times maybe. No? Just 3 times? 3 times? No, 4 times. Looks like 4 times. Okay. So we need to know that too. So 56 goes into 168 3 times. So we're going to multiply the top and the bottom here by 3. And we'll end up with 2 fractions that have the same, 2 sets of equivalent fractions that have the same denominator. And this will be 4. So the first one, 3 times 1 is 3. 3 times 56 is 168, right? That's what we were working on. And we're going to add to that. 4 times 5 is 20. And 4 times 42, that's 160 plus 8, 168. Well, now we can almost do it in our heads. 3 plus 20 is 28. 3 plus 20 is 23 divided by 168. Okay. So 23 is a prime number, but we don't know if that will factor into 168 or not. So what we could do is do a quick prime factorization. And actually, we've got one down here. 2 cubed times 3 times 7 is the prime factorization of this. And 23 does not appear anywhere in here. So this fraction is good. We don't have to reduce it. 23 and 168 are co-prime. We're done. Okay, let's shift quickly to 9/70ths minus 1/105th. So I don't know if you guys are thinking how many times 35 might go into these, but I think that might be a clue. We're going to go ahead and do a prime factorization here. And we're just going to jump in. I'm going to say 3 and 35, and then 5, and 7. So the prime factorization is 2 times 5 times 7. And on this side, we have 3 times 5 times 7. So we have to try something of everything. So we're going to take all of this and this from that other table. And we'll have tried everything. So 2 times 5 is 10, times 7 is 70, times 3 is 210. So our LCM is 210. And that means we need two numbers we're subtracting. We've got something over 210 and something over 210. So to turn 70 into 210, you multiply by 3. And to turn 105 into 210, you multiply by 2. So 3 times 9, 27. 2 times 1 is 2. We have 27 minus 2 will be our answer. 25 over 210. And as you might have guessed, WAMAP often makes us reduce the second fraction. We're getting a little confidence, and then they want us to take it one step further. So using our divisibility rules and a different color of ink, right? We are going to, let's do purple. We're going to take out 5, divide the top and the bottom by 5. So 5 goes into 25 5 times, and 5 goes into 240, and then into 10 2 times. 5 over 42. And if we do a prime factorization now with the numbers smaller, we've got prime factorization of 5 is prime, and 42 we could get 2, 21, 3, 7. So no factors in common. They are 5 and 42 are co-prime, and that's as far as we need to go. So let's plug these in at WAMAP and see how we did. So the first answer was 23/168. Awesome, got that right. Good job, team. And then the second one was 5/42. And that looks like that was right too. So the answers look very different than what they came from. It's kind of like your parents and you. Do you look alike or not? So we're getting into bigger numbers, and it's a little more challenging to find a common denominator that works, but using prime factorization, you can break a number down into its strongest roots and then create a number that is factorable by both of your denominators to come up with a new common denominator. And that's what this is all about. So give these a try, and if you get stuck, please message me. I look forward to hearing from you.